All right, chemistry students, welcome back. So, we're going to start to tie all of this stuff together as far as moles and grams and atoms. And the way we're going to tie all this together and tie it back into chemical equations is by starting a new topic called stoichiometry. Now, stoichiometry is a big, impressive chemical word, and all it means is working with balanced equations. When you see this, all you're thinking is, oh, we're going to have to do work with a balanced equation. That's all that this big, scary word means. And we've worked with balanced equations before. You guys are all pretty much experts at balancing equations by now. So let's just learn the only new thing that has to do with stoichiometry and what problems are entailed in stoichiometry problems. In order to do that, we're going to look at a pretty simple equation. So we have the balanced equation of nitrogen gas reacting with hydrogen gas to produce ammonia. And this equation balances with the coefficients of 1 for nitrogen, 3 for hydrogen, and 2 for ammonia. Now I'm sure you're tired of me saying this because I've done it in 3 videos already, but we can read this in one of 2 ways. We can read it and say, okay, well that means that if we take 1 molecule of nitrogen gas and react it with 3 molecules of hydrogen gas, we'll get out 2 molecules of ammonia. Or we can read it using moles and say, okay, if we have 1 mole of nitrogen gas molecules and we react them with 3 moles of hydrogen gas molecules, we'll get out 2 moles of ammonia gas molecules. And we've said before that the ratio is the only thing that's important. That creates the concept of what we now know as the mole ratio. So another way to read this is we could say, okay, the mole ratio of the reactants to products in this equation is 1 to 3 to 2. 1 to 3 to 2. The ratio of nitrogen to hydrogen to ammonia, is 1 to 3 to 2. We'll have 3 times as much hydrogen as we do nitrogen. We'll have 2 times as much nitrogen, two times as much ammonia as we do nitrogen. And the ratio between ammonia and hydrogen will be 2 to 3. Okay? So, just from the coefficients in the balanced equation, that tells us what the ratio of each of the products and reactants will be. And knowing that allows us to do some pretty powerful work. So, what it specifically allows us to do is the work that real chemists do in figuring out how much substance of each reactant is needed in order to form product, and exactly how much product is expected to be formed, which is a huge deal in chemistry. So, it allows us to solve questions that seemingly before were really, really complicated, but we can see now are not that complicated. Let's take a look at these 2 questions. So, number 1. If 3 moles of nitrogen gas are allowed to react in this equation, how many moles of ammonia gas will be produced? We look at that and we say, wow, a minute ago we didn't even know what a mole was. How are we supposed to solve this problem? Well, let's take a look at how to solve this problem. So, we have 3 moles of nitrogen gas. And we need to convert that into moles of ammonia using a balanced equation. Well, what we determined is that we can convert between moles of N2 and moles of NH3 because every 1 mole of N2 we put in will spit out 2 moles of NH3. So that says, okay, for each mole of nitrogen we put in, we'll get out 2 moles of NH3. We can equate those things. So every 1 mole of N2 that we consume is 2 moles of NH3 produced through the reaction. So moles cancels. And if we do this, we now have a railroad diagram with everything on the top. So we'll multiply 3 times 2. That means that we would produce 6 moles of NH3 from this reaction if we started with 3 moles of N2. hopefully that was overall pretty simple to see how that would work. The thing is, we can relate any quantities on either side of the reaction to one another using these mole ratios that say, okay, how much of each substance do we need to participate in the reaction? So we can also answer another question that's similar to the first, in that, okay, if we start with 3 moles of N2, how many moles of hydrogen gas are needed in order to react completely with the 3 moles of nitrogen gas that we started with? So if we start with 3 moles of nitrogen gas, how much hydrogen gas will we need? Well, some of you may be able to solve this intuitively, but to do the math, we would say, okay, if we started with 3 moles of N2, we would need to convert from moles of N2 to moles of H2. And we know by mole ratio that for every 1 mole of N2 consumed, we'll also consume 3 moles of H2. So we need 3 moles of H2 to react with each 1 mole of N2 we have. If we put this through a railroad diagram, moles of N2 cancel, and our result is 3 times 3. So we would need 9 moles of H2 that would be needed in order to react with this 3 moles of N2. Now, that's pretty cool. We can look at just this bare bones balanced equation. Heck, we could even have the unbalanced equation, balance it ourselves, and then say, okay, from this reaction, we know exactly how much of each of these things we need in order to get exactly this much product. That's a pretty powerful tool, and we'll be using that in the future. What I want you to see is that I hope you saw that these questions were not that hard. It will never get harder than this in stoichiometry. All stoichiometry relies on this. The only thing that will get harder is that we'll need to combine doing this process with doing this process from the last video, where they won't always tell us how many moles we have. They may instead say, okay, we have 10 grams of H2. How many grams of N2 will we need? Well, that's a slightly more complicated question that I'll cover in the next video, but all we need to do is say, okay, if we have 10 grams of this, I can use this chart to figure out how many moles that is. Once I have moles, I'm answering this question to convert moles of this into moles of this, and then I need to convert from moles of N2 back into grams using this process again. So I'm going to show you in one more video how to combine these two processes into a longer railroad diagram and to answer even slightly more complex questions. But it will never ultimately get more complex than this. As long as you know how to do this and how to do this independently, all we're doing from here on out is combining them. And we'll spend a whole unit working on that and doing that. I hope that was enlightening. Let me know in the comments if you need me to clarify anything, and hopefully you have learned something from this. Thank you all for listening, and take care. Have a good night.